Welcome to part 4 of the series entitled Physics in Action. In part 1, an overview regarding the formula on law on tensions was briefly discussed, and in this video we will go into the details of solving sound wave problems. The formula is a simple ratio and proportion concept where F represents frequency. And capital F as the exerted or applied pressure on a string. The F prime represents the frequency of another sound specimen, while the F prime, capital F prime, its corresponding force. Notice the formula has a square root involved, and I already discussed that in one of my earlier videos. For simplicity, however, in calculations, the solutions will be based on cross multiplication and transposition technique. For example, 25 over 50 is equal to 10 over the unknown number x. So all we have to do is cross multiply to give us 25x and 500. And by transposition, we will get x. One thing to remember though, there must be at least 3 variables known in order for the formula to work. So let's say you found a variable here, you need data here, and then you need data here. Before we go to the calculations, I want you to imagine a cord like this being stretched and then hit on its surface, creating a sound. Pianos and guitars behave in a similar manner. Now most of you may be wondering how chords work. And this is how. For example, the frequency of F sharp propagates into the air as a wave. For example, like this one. And then D sharp propagates in the air like this one. Or C sharp propagating like that. Now combining them, if you play them simultaneously you will have a combined wave. Let's say now this results into the chord called D. The resultant wave being one single wave. 3 different notes resulting into one note, which is chord D. I want to direct your attention to this table. Notice that it has only 2 entries for C4 and C5 on their columns. By the way, C4 to C5 is 1 octave. This is Do, Re, Mi, Fa, Sol, La, Ti, Do. Do you think the data would suffice to find the applied force and frequencies of the other remaining notes? For example, your professor wants you to find or supply the missing data using only these 4 values. Do you think it's possible? Well, it helps, but not quite. Remember that you need 3 variables, right? You need to fill in 3 variables in the formula in order to solve it. Now, to demonstrate your situation, let's solve for D. Now, if we look at the table, we have 261 as its frequency for C. And we have 50 newtons corresponding applied force, but then we don't have M sub prime and the other variable. However, we need 3 data, right? So what do? We go to google.com and type frequency of say for example note D, and then it will show to be around 293.665 Hertz. So we write it down. Now we have 3 data available for us. So this one becomes now solving for the applied force. Oops, sorry. Squaring both. Since the exponent square, if you square it, you're canceling the square root here. So we get F 62.99 newtons. Now we can supply the data sought here. So that would be 62.99. Now suppose we want to find the applied force for E4. But this time we will be using the data of C5 here instead of C4. Although we can use C4 or C5 or even D4. Any of the available data will do. So let us solve for E. Now we have the frequency of C5, it's 523.251, and its corresponding applied force of 200 newtons. Then we have to solve for. Now again, we need 3 data for this formula to work. We only have 2. So repeating the steps, we have to find the frequency of E4. And to do that, we have to go to Google again. Now Google said frequency of E is 329.628. Now we can solve this one. And eventually we will find the F as 79.379. Now we can supply this one to E sub 4. Again, Google said 329.628. So we write 329.628 and we find the applied force as 79.379 newtons. Looking good, right? So it's possible to find all the other data that we need. Eventually you'll end up with these data. Again, you have to find the precise frequencies. You have to Google this one. All the data in this column. Talking about practical application, this is C4 to C5. Mi, Fa, So, La, Ti, Do. Implications. As you move up one note to the other, the higher the pitch. That's one. Another, it also means that higher notes require greater pressure or F sub prime, and that means the bigger the ouch as you move up a notch. And that's the reason why guitarists form calluses on their fingers. Some important notes. Do not try to extrapolate on the values of frequencies. Physicists designated them from precise measurements using sonometer. So it may seem that, for example, light waves are equally spaced when they're not. It's the same with sounds. So let's say this is a rainbow with the different colors of red, orange, yellow, green, blue, up to violet. So, although you think they are spaced equally, they're not. So I think that's it for today. And that is how to create an online learning module.